So I think we can start now. Welcome everyone. So this is the welcome for the digital engineering students. Are you all digital engineering? Yes, great. Welcome to Weimar, welcome to Bauhaus University, and congratulations for being accepted here and making it on time. So there were some changes with visa regulations and all kinds of obstructions that the students had to deal with this semester. So some of the students might only be listening to this online later on. We're recording this and it will be shared. In order to easily record this, we're using the room microphones. So if you ask a question, then just speak up a bit so that the others can hear what the question is. We will not record any video, so don't be afraid of that. If you want to ask a question, but you don't want your voice to be on the recording, then maybe write your question on a piece of paper and take it here. There are no cameras on the recording, so that's an alternative. Okay, and this session is an information session. It will be me speaking most of the time, but there will be times where you can ask questions, and then there are some colleagues from different groups that will also be speaking towards the end to tell you a bit about specializations of certain subjects inside the digital engineering degree program. And if you have any questions, just anytime, feel free to interrupt and ask. So the first thing, we're going to start some bit of questions from me to you. So if you have a mobile phone, please scan this code or use this URL. And I'm just going to get it going.
Are there any HCI CS4DM students in here by chance?
Okay, so just scan this, and then once I will move to the next, once I'll show the first question, the code will be gone, so scan it now, and then we'll start with the first question. It will always be the same URL, the same page. You can just refresh it when I move to the next question. So let's start. The first question is, what does Bauhaus mean to you? And this is like a word cloud question. So once you start answering, we will see some of the results. So the word Bauhaus, yeah?
How can you connect with the Wi-Fi?
It's for the Wi-Fi. You need your username. Do you have the username of the university?
Yeah.
Yes. So it's this username, the letters and the digits, 3 or at uni-weimar.de, and then your password in eduroam.
It's eduroam, right?
Yeah, it's eduroam. Eduroam is the Wi-Fi that should work in most universities in Europe. So if you go to some other city already at the train station, you might be able to log into the Wi-Fi of the university using your username and password. But also on the laptops, the configuration of eduroam might be a bit tricky sometimes. There might be certificates that you have to install, and some Linux versions, they might make it not so easy. So there are some websites which you cannot reach when you're offline, right? But they'll basically allow you to download some installers. But usually on your phone it should really work.
And there are some tips and tricks if you add the suffixes at uni-weimar.de to your login, then you can log in at all other European educational institutes, and you are automatically connected. But yeah, as Jan told you, there are like pages of instructions. If you just search for WLAN Uni Weimar on Google, you may find instruction sets. But you don't have internet right now.
I have connected with it.
Okay, great. So we have some answers here already. Different perspectives. Architecture, yes, it's very well known for architecture. There were some famous architects here, and there are some buildings in different places of the world that are Bauhaus style. Hardware store, okay, yes, there's also a hardware store that's called Bauhaus. And then somebody knows a bit of German and says building house, literally, yes. I guess that's why the hardware store took that name, but I think it's not as old as the Bauhaus movement, so I haven't checked it. Does anybody know when Bauhaus was founded?
In the early 20th century.
This one, ours.
The university?
Yeah?
I don't know.
Okay. Yeah, 1919 or something like that. Sometime that era, yeah. Okay, then
1960 in Mannheim.
what?
1960 in Mannheim.
That's the Baumarkt. The Bauhaus. Yeah, so we are older. We had the name first. Yeah, a design revolution. Yes, function over design. Or this famous form follows function. It was also a little bit about mass production, but that's all the historic aspect, right? I mean, architecture and civil engineering, that's, well, historic, but also current, right? So that's still something we have at Bauhaus. Education, visualization, interdisciplinary. Yeah, that's, I think that's the thing that our university values a lot, that we are interdisciplinary between different faculties. Even this program here, the digital engineering program, is interdisciplinary between two faculties. And we also have some elective parts where you can actually take stuff from even more of the faculties that we have. So even from the arts faculty, you can take in some credits into your degree to a certain limit. And we will see that yeah, soon. Okay, so a lot of stuff. Preferred university, yes, of course. That's what it should mean to most of you. Art and culture, yeah. Good. So you already know a little bit about Bauhaus. I have some slides. We can probably go over them quickly. So it's a, well, kind of very special place with a great tradition. It was founded in Weimar, but then it also moved to other places. But this is where like a famous art school, design school started. And Bauhaus kind of stands for the unity of arts and technology. And maybe you know some of these names here, or maybe you will go on some tours and then you will see some of those names appearing, yeah, famous artists, architects, and some of the art and some of the artifacts that they created here, they're actually still visible in parts of the university or outside of the university, like this building here. And also in the Bauhaus Museum. So one thing, there are a lot of museums in Weimar, and I think the third Sunday of each month, they open for free after maybe 2 o'clock. So then you still have like 2 or 3 hours to visit the museum and you don't have to pay. But it's only like, I think every third Sunday in the month or something like that. You can look it up on the website of the Klassik Stiftung that runs most of these museums. And yeah, otherwise you have to pay the entrance fee, but those days, if you watch out for them, then you can get into the museums for free. Okay, yeah, but that's Weimar and the old Bauhaus, and there's of course the new Bauhaus, and there is digital engineering. And the key idea of this study program, which most of you have probably seen, it's an interdisciplinary course. So we have people from different areas of engineering, and maybe some people from computer science or different areas around computer science, right, that can start this program. It's a 2-year course, so it's 4 semesters, and it's entirely in English. So about, I think, more than 30% of the students in Weimar, here at Bauhaus University, are international students. So there are a few other master's programs which are also in English. So you have enough courses that you can take for your degree that are offered completely in English. And it's essentially about skills for Industry 4.0, so maybe the customization, this German initiative to digitize and automate industry even further. And there's a strong focus on civil engineering, but let's see what is your maybe background, where do you come from, what did you study first? So let's see what countries did you study in before. So you might have to refresh the page to see the next question, if it doesn't appear automatically, but it's the same URL again. So I think this thing is weighted, so the more people that put one country, the larger the country will appear here. Usually there are a few more countries on the slide. I guess not everybody could make it. Yeah, so only two answers, India and Germany. Yeah. I mean, we know this kind of from the statistics, but there's usually, you will see that there's a broader variety of backgrounds that people come from in different countries, not only India and Germany. Yeah, you will see that in the coming weeks when you go to different lectures. The nice thing is that the lectures, we have a lot of areas in your degree where you can choose different lectures, and then you might sit in your first semester in a lecture that somebody in their third or second semester is also taking. So the community kind of mixes nicely, and you can talk to the, let's say, older students, the ones that have more experience, and ask them about other modules. So usually this is quite helpful, because we don't have this strict schedule that says this is what you do in first semester, then this is what you do in second semester. There are a lot of choices that you can make depending on whether you feel ready for them or whether you want to build more of the foundations. So yeah, we will see that later on. But now another question: what fields do you hold degrees in? So yeah, what's your first degree? Maybe you had different ones. We have mechanical engineering, civil engineering, and computer applications. Okay, so yeah, sometimes we also have electrical engineering, applied computer science. Yeah, so we have some from the, let's say, digital side and some from the engineering side. That's very nice. Okay. Good. Now, let's go back to the slides. The things that you might do afterwards, that's maybe even more diverse than your background already, right? So you can work in many areas of industry. There will be maybe options in almost every branch of industry where they basically need the people who understand the digital world and also the engineering world, right? So you could be model managers or analysts or system integrators or project managers, right? Because usually projects are not just done between, I don't know, civil engineers and only civil engineers. Maybe other people are involved, and then often there are maybe some computer science people involved, and then you need somebody who can basically build the bridges between them. And this is basically what we are trying to teach you, to basically build these bridges and develop new things that each side alone couldn't, because they may be missing the knowledge, or they're not able to communicate efficiently and effectively the way they should. But we have also seen some students that go into maybe software development, so basically just on one side of this branch, maybe data analytics in banks, where you don't have that much engineering anymore, but a lot more, let's say, computer science and data science, but also, of course, more in the engineering area. Some people also go to companies which do mechanical engineering, stuff like that. So there's really a wide variety of options afterwards. One thing about our studies is that they are quite project-based and research-led. So in the different areas that you will see in the module handbook, the people that are teaching you, they usually do research in this area or a very related area, right? Sometimes they teach you the foundations, but then they maybe tell you also what kind of research they do based on those foundations. And in the projects, this is something that usually happens in the third or fourth semester, and maybe also your final project. This will always be related to some research. So in the master's project and also in the student projects, these will be group projects that you do maybe in groups of 3 to 10 students. You work on some research projects that are proposed by the different professorships in our university. And usually you work with PhD students on very up-to-date current topics in their field. And this is the curriculum overview. So this fits quite nicely with the time that you're starting. These blocks here, they are colored in different colors because they are the fundamentals that you have to do. So the blue ones, they are your fundamentals, the ones that you got in your acceptance letter that say these are the 3 modules that you should do, and this depends on your background. So based on the background, the selection committee basically decided what is it that these students best need to, let's say, learn so that they will be on a comparable level to the other students. Then there are the 2 main other colors. That's the kind of, yellowish and greenish colors. And they are about engineering methods. That's one big block where you have to get a certain number of credits. And the computer science methods, that's another block, which is only half the size. But that's also where you can select different modules. And we will see on the next slide the possible modules that you can select there. Then you can fill your schedule with electives. So these are modules that are not necessarily in those blocks, but maybe even from other degree programs that you're interested in and that you want to complement your studies with. So that's in total 12 credits, but those 12 credits, they're usually split into 6 credit modules or 3 credit modules. So 3 credit modules, they're only allowed in the electives. In all other blocks in the engineering methods and the computer science methods, you will usually have a 6 credit module. Yes, and then we have these research projects that you do in groups, and then the master's module, which consists of some initial research here, and then your actual master thesis, where you do some research in an area that you're interested in, and that you find a professorship to supervise you. This is another view on kind of the same thing, but now not spread over semesters or years, but just listed. This is part of the module handbook, and the module handbook updates from time to time. So it's always good to have a look at the latest module handbook. We're going to add very soon another machine learning for structural dynamics module, for example, which is not yet on these slides because it will only be offered next semester. But other modules are popping up and being added to the modules that you can take. And they are usually categorized into either engineering methods or computer science methods. And then the electives, they will not be in the module handbook because you can pick them from almost anywhere you like. If you're really into, let's say, computer science, you can also take additional modules from computer science methods into your electives. That's also possible. And if you want to do more than 120 credits, just because you feel that there are some very interesting modules, and you still want to take them, although you already completed the mandatory ones in terms of the numbers of credits, then you can also do that. And they will appear on a separate transcript that will be attached to your final master's certificate. So this will not be lost. They will not go into the calculation of your final mark, but you can still demonstrate that you have them, and there will be an official document saying you did this and this is the grade you got in that module. Okay, now this was the general overview, and this is the timetable for this semester. I don't know if you've seen this already. As soon as so it's on the website of the digital engineering program. And as soon as you are all registered in the mailing list, this will also be sent on the mailing list. Now this timetable is quite full and it has quite some collisions, right? So you see here that algorithms and data structures here collides with microscopic traffic simulation, hard fundamentals, and indoor environmental modeling with microscopic traffic simulation. Wow, this has quite a bit collisions. But also here, generative software engineering and introduction to optimization. So doesn't look good that this stuff collides, right? But the reason that it collides is we just can't fit it in any other way. And you will only pick some of these, right? So every semester, you usually do 5 modules. So for example, just picking them because they are fundamentals. So many of you might have to take the algorithms and data structures and the software engineering as fundamentals. So if you're from an engineering background, not from a computer science background, then you would take algorithms, data structures, software engineering, and usually they will come with exercises as well. So for example, if you pick algorithms and data structures, then this block is kind of taken, and there'll be another block somewhere. Where is it?
Tuesday afternoon.
Tuesday afternoon, algorithms and data structures, yes. So that's the exercise, that's the lecture. For software engineering, that's the kind of lecture and exercise alternating, and again, lecture and exercise alternating. So those 4 slots are blocked by taking those 2 modules, right? And then there'll be additional stuff like homeworks. And then you can check what other blocks are still available, and you can pick those that are still matching your schedule. So for example, the advanced building information models, or modeling,
Advanced building information modeling.
Modeling, yeah. And then, so usually each 6 credits module has kind of 2 blocks in the timetable. And it's a good idea to talk to those who have maybe done some of these modules and ask them what they were like, but don't get misled or discouraged. So for example, I'm teaching this generative software engineering, and the second year that I was teaching it, the number of students was very low. And the students that came, they asked me, is it really true that like more than half of the students are failing this course? And I told them, no, it's not true. So there are sometimes rumors that some courses are really difficult. Maybe try them anyways, right? Don't be discouraged because other students might tell you that they are difficult. Talk to the other students, but don't make decisions only based on what they tell you is easy, right? Okay. And then there is a new thing, well, not so new anymore, but it's quite important. It's so new that the older students, they will not be able to tell you much about this. And that is the profile lines. So this is like a specialization inside the digital engineering program. And there are 2 profile lines, and very soon you will hear from different colleagues a little bit more about these profile lines. This slide just has the main organizational stuff. So there are 2 profile lines at the moment: materials and structures, and mobility and transport. There are some requirements in your studies that if you fulfill these requirements, then you can say, well, I want this to be recognized as a profile line. And then I want on my final digital engineering certificate, I wanted to say that I studied digital engineering with the profile line, mobility and transport, or with the profile line materials and structures, but you don't have to, right? So this is not a must. You don't have to pick one of the profile lines and then study that. And you can still take the same courses, but some students, they really want to specialize in one of these areas and they want this to be written on their certificate, and then that's why we offer you to do these, study these profile lines. What is formally required is that you have 60 credits, so that's basically half of what you're doing inside this profile line. So how do you get 60 credits inside this profile line? There are some of the engineering methods which are labeled with each profile line. So these are the modules you can take in engineering methods. Then here you see they might be associated with the structures and materials. The ones that it says here, how many credits would you get inside this profile line, right? So by picking your normal modules, you might already earn credits in your profile line. This works for the 2 blocks, engineering methods and computer science methods. And you need 18, so that's basically, again, like 50% of the stuff that you do in engineering methods needs to be related to the profile line. In computer science, it's basically 2 of the modules need to be related to the profile line. And then your project could be this research project that you're doing in the 3rd semester. This may be related to the profile line. This allows you to fill up those 60 credits, right? You don't have to do that. For example, you can fill up those credits in other ways, but the project gives you 12 credits, so that's also a good option to kind of fill credits in the profile line. And then your master's thesis, the topic of that, this also needs to be within the profile line. Otherwise, you're probably not going to get those credits filled. The master's project is 24 credits, so that's big, because the idea is basically that you're almost for like 8 weeks only working on that kind of research, right? And that's why we give you the 24 credits for it. And then the elective modules, for example, you could pick some additional modules from engineering methods to put in your elective modules and then earn profile line credits from those. So that's also optional. So what's really mandatory is the engineering methods, more than 18 credits, computer science, more than 12 credits in the profile line, and the master's module. And then you can see how many credits are missing and how do you top them up to basically make it to those 60 credits. And the details, some colleagues will tell you. Now, some general advice before I hand over to my colleagues. So there are some language requirements. So for example, for your master thesis, you need to show that you have English level C1 and that you have German level A1. If you don't have those yet, you can take language courses. So there will be a language course for English C1, which will be called, I think it's called Academic Writing. And this will be announced on the mailing list. So very soon you'll be on the mailing list, and then you will receive emails, and there'll be an email about registering for this academic English course. Then you can register. And then this course gives you some credits, and these credits you can use in your electives, right? So it's not formally part of engineering methods or computer science methods, but each language course gives you 3 credits, and you can take that up to 6 credits of language courses you can take in your elective modules. Now that's very complicated. I'm saying up to 6 credits here and 3 credits there. That's all written down, and you can have a look at the study regulations and examination regulations. There you will find all these details. And the links will be on the next slides as well. Yes, then one thing about German language is, wait, do I have a question about this? Yeah, what's the highest level in German that you have? Just to see what, yeah, wie gut Sie schon Deutsch sprechen können.
Ich wüsste gar nicht, welches.
Die machen halt auch mit, ne?
Ah, we don't have the option lower than A1. Anybody lower than A1? Okay. Sorry, I didn't include that. Macht auch mit, aber
No. Also ich schon.
okay. One person has a higher level in German. Good. Many have A1, some have A2. Okay, so those language requirements, yeah, they should be possible to achieve, but with A1, it will be very difficult, for example, to get an internship or to get a job afterwards. I don't know what you're planning to do afterwards. Some students, they plan to stay. Some students, they plan to go elsewhere, outside Germany. But those that stay within Germany, for them, we have heard that it's really beneficial to speak German to some extent, right? So, and that extent is is greater than A1. So some students might have B1 or something.
B2.
B1, B2. That's helpful to get a job in some places. In some larger companies where they have international teams anyways, you can also get a job just with English. But yeah, those are maybe a bit rare. So some students, they move to Frankfurt to work for a bank, and then, yeah, English is fine. But like acquiring those language skills is not easy, and it needs to be planned. So if you're planning to learn German, then make a plan right now, because soon it will be, I don't know, second semester, third semester, and then in fourth semester, if you start applying for jobs and realize, well, you haven't really learned German yet, it might be a bit difficult to catch up. Some students, they like do a holiday semester or vacation semester just to do an intensive German class or something like that, right? That's also an option, but it, of course, would extend your time that you're before graduating, right? Okay. Another thing that's important, you're expected to earn about 30 credits each semester. Now, that's 5 successful modules, right? And each module maybe has 2 sessions, but they also have homework and stuff. So this might sound easy. And in the beginning, you might think, well, I'll maybe sit in 7 or 8 modules if they don't collide in the timetable. But you'll probably realize that even achieving those 30 credits, it's really kind of like full-time studies and not doing anything else, and really focusing on completing those modules. So this requires some effort. We sometimes, well, we don't necessarily track how many credits you do each semester. So nobody will say, oh, last semester you only managed, I don't know, 18 credits, you really need to catch up. This is kind of your responsibility, right? If you need longer, then you need longer. And we have some students that need longer until they eventually graduate. Yeah, just be aware that that's quite tough to get those credits in and complete. And each credit roughly compares to 30 work hours. So 30 hours of work, and then you look at the timetable and you say, we only have 2 sessions per week. How am I like going to get those hours of work in if I only have to show up twice per week, right? But that's not really the case. The work hours, they're usually calculated based on time that you need to prepare the lecture or basically revise the materials, and then it also contains the homework and stuff like that, and studying for the exam. So it kind of makes sense to equate those 30 hours, but then if you calculate that based on the semester, then you see that it's really a full-time job to get those 5 modules completed. Yes, and then there are some stipulations that you have, so that's the 3 subjects that were written, the fundamentals that were written on your acceptance letter, like the algorithms, data structures, software engineering, introduction to object-oriented modeling and programming, and those you should complete within the first 3 semesters. So you have to complete them before you do a research project, because these are basically the foundations that we say all the students should know from the different areas, so that they are on some, let's say, comparable level, right? So this semester you saw that you can already do 2 of those. If you have the non-computer science background, then the algorithms, data structures, and software engineering, you can do 2 of them, and then maybe the object-oriented modeling and programming you do next semester. Yeah. So yeah, keep an eye on those fundamentals that you have to complete. Yeah, some more advice. The fundamentals have to be done before the project can be started. And your research project, this is this 12 credits one that is in the 3rd semester usually. You have to complete it before the master's module can be started. And there is an initial research that you have to complete before the actual master thesis can start. So this one you can usually do maybe in the semester before you want to start the thesis and before you want to complete the thesis. Once you start the thesis, you have 8 weeks. So you can time that maybe for the last semester. And then the initial research, you have as much time as you want for that. But it's a good idea to not leave it sitting for too long. So just do it the semester before you do the actual thesis. Some other students, they suggested that internships are really helpful for finding jobs later on. German skills are required for many job opportunities. And in general, master thesis with companies is not so easy. So we have some students which are lucky and they find a company. The company hires them for the duration of their thesis and pays them even a small salary, and they do their thesis with us here. So the thesis always have to be supervised by a professorship in our university, or maybe in exceptions in another university, but that would have to be going through the examination board. So usually it's at least one professor from our university. And sometimes companies, they say, oh, we have a list of master thesis topics that you can do with us. The challenge then is finding a professor who agrees that this is a worthy master thesis for our university. So just be careful, because usually sometimes students ask me to supervise some master thesis from some company, and then either it just sounds like they want the student to do a lot of boring work and call it a master thesis to get a student working on it for free, or sometimes it's just not in my area of expertise, and then I tell them, well, see if you find any supervisor for that, but it's usually tricky. If the company is more flexible, it might work, but there's no guarantee, and it's not integrated in our program. It's possible, but not so easy usually. Okay, and the study regulations, which are on the digital engineering landing page, you also find the module handbook where you can see all the modules. Those are quite important resources. Now the next steps, there's this website. I'm not sure how good this information on there is about starting finding your way in Weimar. Then this was some piece of advice on math courses. So some of the courses are not only offered for digital engineering, but also for other study programs. And then these other study programs, they might allow a 3 credits module. But in digital engineering, if you want it unless you want it in the electives, if you want it in the computer science methods or in the engineering methods, then it has to be a 6 credits module. So to make that possible, some of the mathematics modules, they are split into 3 credits lecture and a 3 credits exercise. Then you have to do both, right? So some students, they might only do one of them because they only need the 3 credits because they take it in the electives. But if you want it in the engineering methods, you have to do both, right? So just have a look at the module handbook, what it says. And if you do a 3 credits module somewhere, then be aware that this usually means you have to do the other 3 credits of that matching module as written in the module handbook, or you take it in the electives. If you take it in the electives, it's usually no problem. Okay. Yeah, there'll be a feedback conference that we will organize at some point where we hope that some of you will join, where we're just checking on how the studies are going with everyone in some seminar room. One thing, because some students were not so aware of it, failing modules is serious. So don't fail your modules. If you do happen to fail a module, you can usually register for a second attempt. If you registered, or if you also fail the second attempt, you have to apply to the examination board to be granted a third attempt. Usually this third attempt might be with some restrictions, so maybe they tell you that you have to do the homeworks again, or that you have to visit the lecture again for your third attempt. Then after you've completed that, and hopefully you're past your third attempt. If you fail the third attempt, then that's it for not only this subject, but in general for your studies. So if you fail the third attempt of something, then you're exmatriculated from the university. So don't fail your third attempt, right? That's why you have to apply for that, so that the examination office can really tell you, well, be very serious about the third attempt, right? So don't fail that one. Yeah. I mean, if possible, don't even fail the first attempt, right? But this usually happens, right? There's, I don't know, maybe 20% or, I don't know, more, sometimes less, that fail a module. And then they redo it the next semester. Many modules you can redo the next semester. Yeah, and check your university emails regularly. There might be announcements on there. In the beginning of the semester, there might be many, many emails. Try to still go through them, see which ones are relevant, and yeah, don't just ignore them and only look at them, I don't know, at the end of the semester or something like that. Yeah, you will be soon on the mailing list. If by next week you're still not on the mailing list, then contact Ruby Richter, please. But everybody who is immatriculated, they'll basically get, they'll extract the email addresses from the database and put you on the mailing list within this week. And then you will notice that you're on the mailing list because you will see the somebody sending the current timetable for digital engineering. Okay, some upcoming events. The lectures are starting today. So some lectures already started today. I'm guessing that most lectures relevant to you, people know that you're arriving today, because also the other master students of the other programs, they're arriving only today, right? So I'm guessing that most first semester modules are not starting today, but they probably start tomorrow. So have a look at the schedule quickly. Then there's the project fair today at 5 in the Audimax. That's in Steubenstraße. You can go there and see what kind of research projects we are offering, but you cannot yet register for them. So this happens every semester. So you could also decide to only go next semester, because the first time you can really register for them is when you have passed your fundamentals. So normally these research projects you'll do in your third semester. You can also go there when you want to do them in your third semester, but maybe you already go there in the second semester to see what they're offering, right? So for first semester, maybe it's not that relevant. Yeah, then there'll be a lunch with the student tutor and also Matthias Artus, who's the program advisor. Yeah. And this will be tomorrow. And I think it will be at 1 o'clock, but it might also be at 11?
I don't know. My last information was at 1, but now I heard that several students were thinking about to take advanced BIM, maybe wanted to attend. That was the reason why I'm thinking about 11, but to also tell you, advanced BIM won't start tomorrow.
Yeah, so
we'll
it's
keep it at 1.
kind of, yeah, let's keep it at 1 because it's on the slides, and I think that's the last information that was maybe communicated
Yes.
to some of the faculty members. Okay, great. Yes, and now I think we will go into a bit of the details of the profile lines. I'm not sure which one we should start with. This one is open right now. Yeah, maybe we should start with this one.
Okay. Do I have just 5 minutes or maybe 6, 7?
Yeah, maybe 6, 7.
Okay, that's no problem.
I mean, we're...
Yeah. Welcome to my talk. So my name is Thomas Most. I'm from the Institute of Structural Mechanics at the Faculty of Civil Engineering, but I will try to explain you these red marked modules. One is not in this track, I think, but it belongs somehow to the topic. That's why I've chosen this. Yeah. Okay, so we have mainly, if you look on this, I think 3 main topics: more detailed modeling of mechanics, then math-based methods like optimization, stochastics, and then also dynamics. Yeah, that's why I have subdivided these into. Oh, what should I do? Is it already full screen mode?
I don't know. It's a new PDF tool, so okay.
Abspielen. Da oben hast du was abspielen gehabt.
Nicht hier?
Ja. Nee, mach mal kleiner wieder, mach mal wieder kleiner. Und da oben hast du was abspielen. Bei den großen Dingern.
Okay. Yeah, now it works. Okay, 1 minute per slide. So, but then you have time for questions. The first block belongs mainly to modeling, structures, and maybe other systems from the mechanical viewpoint. One module is finite element methods. It's provided in the winter semester by Professor Rabczuk. And here you have the typical topics like introduction to finite element methods, then nonlinear problems as well, and then also a dedicated part of the module to applications. Yeah, so going from geometry to mechanical modeling, and then representation of the structures. Here, a written exam is done at the end, and might be also interesting that this module also focuses on mixed finite element methods, where Professor Rabczuk is well known worldwide for his research in this case. And then we have a quite new module. It was not on the list, that's why, but I have added it because it's in the.
I will also add it to the module catalog. I have it on
It's in the module catalog already.
It will be in the module catalog also for the profile line. I have not added it yet.
Okay, but it strongly belongs to structural and materials. It's mechanics of materials of our new junior professorship, and yeah, it deals with the modeling of different types of materials, going from the observations of the phenomena like crack propagation to representation on a more high-level scale, and then going down to the modeling in an analytical or numerical model in this case. Again, a written exam is here necessary. And then we have a third module which fits to this overall modeling and analysis of structures framework. It's modeling of steel structures in numerical simulation. It's application of the finite element methods dedicated to steel structures with some quite interesting phenomena like stability behavior and also nonlinearity. So here you will also, I think, model the welding and all these stuff in a more detailed finite element model. And it's provided by Professor Kraus from the chair of steel structures in this case. So these were these 3 modules which belong to mechanical modeling of structures. And then we have here 3 others which belong to mathematical improvement and assessment, maybe of structures, systems, whatever. One is design and interpretation of experiments. It's not just design of experiments from the numerical viewpoint, it's also how to design real experiments. Yeah, not just the mathematical design of experiments. Maybe some of you have heard that you adjust some factors and find a good sampling scheme or whatever. This also is dedicated to look on how to design real experiments for different observations, different phenomena. And then one specific part in this module is this signal modulation transformation, where you also learn here different types of filters, modeling algorithms, and so on. Here there is a project which I think contributes 1/3 to the final mark, additional to the exam. This is the same for all 3 modules provided by Professor Lamer. So here we have also the 1/3 contribution of this project you do during the semester. Yeah, optimization, which is more a fundamental subject in this case. Here you learn the fundamentals from the mathematical viewpoint, linear, nonlinear optimization, constrained, unconstrained, but then also in applications you do topology optimization, which might be also quite interesting in case for applications for structural improvement. And the third topic or third course in this main topic is stochastic simulation techniques in structural reliability, which deals with risk assessment. So for this you have to model somehow your inputs, your loads, whatever, by uncertainties, and then analyze the uncertainties with some special statistical algorithms. So you learn here the basics, but then also going a bit more in the details of reliability-based design, sensitivity analysis, and risk assessment. So here some more advanced algorithms are maybe necessary, starting from a simple representation of random numbers. Yeah, and then we have two modules dealing with structural dynamics. One provides you the introduction to the mechanical modeling. So we start with vibration analysis of simple systems, then model analysis of more complex systems. Then we investigate or model here dedicated the vibration absorbers, which might be interesting. This is a vibration absorber in a skyscraper in Taipei. So this is the mechanical model. So you can do this on a sheet of paper. And then we have here a dedicated part of this course on applications like earthquake excitation, wind-induced vibrations, and so on. Here we have a little project which is necessary that you can take part in the exam, and you have to program some things, and then we have a written exam. This is in the winter semester, and in the summer semester, there's a course which you cannot attend in your very first semester because it requires fundamentals of the structural dynamics. Yeah, so you have to. That's why I put this on the end. It's the only course I think here on this block where you need to attend on a previous course in this case. And then for a selected number of students, there are just maximum 10 to 12 students, we go to the lab and do experimental structural dynamics. So we have small specimen structural members here. We investigate it by measurements, do then the numerical modeling and the model calibration of these measurements. Here we don't have an exam. It's the only course in this, but here you have to do a project over 2 months. So, and then give a final presentation and writing a report. Yeah. That's from my side so far. Yeah. So, but if you have questions, I think we have a few minutes, but maybe also afterwards. Yeah. You can.
Yeah, maybe we can collect the questions afterwards.
Yeah. No
Is there anything right now?
Hey. I am Leon Tiebes. I'm representing Professor Planck-Wiedenberg, who's the chairman for transport system planning here at our university. We are focusing on inner city transportation systems, but not only the technical side of it, but also the safety and sociological questions about it, like how fair is the street designed for different participants, and how to deal with all the conflicts we have. Alone in this one small picture, we have cars, pedestrians, cyclists. We don't see them, but we may get a lot of data from that intersection. And here, you as digital engineers, you are always helping us understanding the data and doing optimizations where where just thinking about a conflict is not enough. So when you imagine, for example, a traffic light, it's not by gut feeling when it turns green and red. There's an optimization strategy behind. So if you're interested in those questions, come to us. We have quite nice job opportunities for you, not only in German, but also in English. But yes, if you want to work as a transport engineer in Germany, most rules, regulations are in German, most presentations. So if you start learn German, that would be totally fine. And then you have career opportunities in public administrations, engineering offices, and software development. And transportation companies like big logistic companies, or being a supply chain manager concerning the logistic and transport. The focus of our degree program here in Weimar is the transformation of cities into more sustainable designs. So here in Weimar, we are concerned a lot about traffic safety and about emissions and emissions of traffic. And we are concerned about mobility. So that's what Jan already presented. You take some of our courses, so at least 60 credit points. But for us, most important, you do your master's module with us and you write your master thesis at our chair concerning a transportation study. And then you get your profile line, mobility and transport. You can also just come to us and try it out, take our courses, and if you don't like it, just don't continue with us. You still get your digital engineering degree. Yeah. Okay, here you see all the other modules again. So now we have like our fourth or third visualization of all the courses available. I would highly recommend you to take the Introduction into Mobility and Transportation next semester. It's an international course with international case studies and international lecturers from other countries. It is always in the winter semester, so next semester. And microscopic traffic simulation would be a very nice start for you this semester, if you don't need to study data structures and algorithms. Yeah, sorry for that conflict. We try to minimize those in the future, but in our courses, we have students from 4 different degree programs, so it's quite hard to schedule without conflicts. We are quite a large team at our chair, but your main contact persons are Professor Planck-Wiedenberg and me, and also Julius Ullmann. And yeah, we would look forward a lot to meet you in our classes. The next class would be microscopic traffic simulation, starting next Monday at 1:30 p.m. But you should only take that course if you don't need to do data structures and algorithms first. Yeah, so you can still do microscopic traffic simulation 1 year later in the 3rd semester. And in the summer semester, of course, in the winter semesters, we also have a lot of electives and are happy to meet you. And I want to emphasize, we want to meet you. Like when you are interested in the profile line, tell us and we can meet and we can explain you everything in detail and give you some insights. Good. Welcome to Weimar and all the best to you. We are very happy you're here and hope your study mates will come soon as well. Yeah.
Okay, thanks a lot. Yeah, so this has been a lot of information. Many of these things you heard for the first time, right? This whole video will be made available. I'll post it on the mailing list as well, so you can review all the information that was given here. And there are a lot more resources like the website of digital engineering where you read about the program. You also see the study regulations there, the examination regulations. So all of this, at least download it and then at one point maybe look at it. Yeah, and so the main points of contact, we also have Matthias here. Willst du dich kurz vorstellen?
Ja, klar. Hi and welcome everybody of you. I'm Matthias Artus. I'm the study counselor, student counselor, or advisor, however you would like to call it. Everything that is related to digital engineering. I'm supposed to help you in many questions of that. I'm working at a chair from Professor Koch, Intelligent Technical Design, and you will meet me maybe in case if you take simulation methods or object-oriented modeling programming.
Okay, and we have a student assistant. You also want to introduce yourself? I mean, probably they all know you, but...
So I'm your student tutor for this semester. I'm currently in my 6th semester doing my thesis. So about me. Thank you.
Yeah, that's his email address, and you're probably already in contact in all kinds of different channels, right? Okay, so now would be the time for questions. So if you have any questions about the profile lines or about the general program or about anything else, then we can try to help you. So please ask your questions now.
I have a question. So, I'm a structural engineer by profession. So, do structural engineering offices need like software efficient people to optimize their workflows in today's job market? So, do you have like an idea about that?
Yeah, I think they definitely do. Maybe not all of them are aware of it. So we're also talking to local companies a bit more. There's some initiative which was started by the city and some trade unions and some local companies and our university to get more in contact with the respective companies. So many of the professorships, they are in contact with different companies, but it's not really centralized, right? So we're starting some, let's say, feedback discussions with the companies in Weimar, around Weimar, in Thüringen, to see whether they want any or whether they have any, let's say, ideas or wishes of how to improve the collaboration. And yeah, so we're hoping to get a bit more, let's say, input and output also from industry and to industry. Many of the professorships, they have their contacts. They can help you find maybe the right companies. Maybe they have some opportunities that they see. Some companies, they do some, let's say, Werkstudenten. This is where you basically work some hours at a company, which is usually quite beneficial. And then some students are lucky and the company hires them afterwards for a full-time job. But yeah, there are many options, but there's not like one way to access these options, right? So you have to keep your eyes open. You have to talk to other students who maybe have done things like that, who have done internships, who have done Werkstudentenverträge, contracts with other companies, and yeah, then see what options there are. So it's usually, it's quite diverse, but I mean, one thing is also the students that we have here. They are really quite diverse, right? In terms of the backgrounds, the degrees that you have, the skills that you have. So it's not just that one company says, yes, we always hire digital engineering students, just because there's so many different backgrounds, right? And so many specializations, and then maybe they are very interested in ones with one particular background and maybe less in those with others. So that's why we're quite unique in digital engineering here. Yeah.
Thank you.
Any other question? Yeah?
Yeah, so there were two profile lines mentioned here. Is it necessary to take either profile line while going, or?
No, you can take the best of each.
Okay.
You can take even other lectures that were not mentioned or are not associated to profile lines. So these profile lines, they're just a new thing to allow some, like, let's say, it's like a lightweight new degree program, right? It's because it's digital engineering with a specific subtitle. So that's just something that we're trying out. There might be more profile lines in the future, but yeah, it's basically, you don't have to take them. You can take the courses right now, and then maybe in your second or third semester, you can check are these profile lines still open to you? And usually they are, because you can still get the project credits there and get the master's project credits there, and then you can decide, do you want them or not, right? So yeah, it's really completely up to you. If you want, you can still take all those courses that are offered or that are associated to some profile line, but just take them as part of your regular studies.
Thank you.
I have one more question. Each module, I mean, most of the modules has a project. So during the project time, do we have to choose one of the topic and we have to do the project, or a professor will gonna give the topic?
So this is again, you will see that this is up to each module or up to each professor how they teach it, right? Some they have this kind of project. Sometimes you have to do homeworks, which are maybe mini projects. Sometimes you have to do very large projects, even to get the final grade. Might be only a project. Well, only, then still means that it's the equivalent of the hours that you would put into the exam and the homework and stuff, right? So this is up to each module. But most of the time, this runs in parallel to the teaching. So yeah, so that's like a maybe replacement for homework or addition to homework. Yeah, but it's really, they will tell you, usually they tell you in the first lecture, or in the second, or maybe the first exercise lecture, stuff like that. So you can also have a look at the module handbook. In some, it says how this works. Sometimes the students can choose the topics, but then you can maybe only start the project after half of the teaching is done, because you cannot choose a topic in the beginning when you have no clue about the subject, right? So it really depends on who's teaching it and how they're teaching it. So it might be different in each module.
One more question. So there are subjects like in structure, and I would like to take some few subjects from computer science. I would like to mix up. Is there any kind of projects can we work with together in the programming side with the structure analysis?
Yes, so
Software development, something like that.
yes, definitely. So usually these these research projects, they'll be the ones that are quite open. So the professorships, they will suggest some topics, and then students will work on them. And often those are like combining different skills. Yes, or sometimes maybe somebody from one area offers something where they know that they want maybe some people who can do machine learning. But they are not teaching machine learning themselves, but that's basically what happens in our program here, that some students who are maybe stronger in the computer science stuff, they contribute to some modules and some research projects in the engineering side. So yes, this usually happens a lot, this combination. Yeah.
In structured analysis part, like in numerical simulation part, so what kind of application, like not application, what kind of tools do we use actually? Ansys, Abacus, something like that? Is it offered in university?
Yeah, so we have university licenses, for example, for ANSYS and some other tools, and you can use also them as a student. You have your VPN login. Yeah, but the courses are not just focused on the application of a software. You really learn what are the basics behind. It's a university course. That's why we also go into the details that you really understand to do maybe some basic implementation of finite elements by hand in MATLAB or Python, and then go for commercial software afterwards. Yeah. That's the same also for optimization, stochastic courses. You really do many things by yourself in a math program or Python program environment, but also combining with commercial codes.
Sorry, I have another. So, like, what programming languages are extensively used throughout the course?
Yeah, what programming languages are used? So this again depends on the course. So it's basically there's some introduction to object-oriented modeling and programming, and
It's
that's
Python.
Python.
Yes,
Okay.
we plan to
Yeah.
switch to Python. Before it was C#, before it was Java. I think Java is still taught, as far as I remember.
So we use some Java in software engineering, and then in other modules, maybe you use Python,
MATLAB.
maybe MATLAB, maybe R. So it really depends because many of them are really specific to the application, right? So for one application, maybe one language is better than the other. So yeah, you're kind of, well, many of them, they will introduce the language and teach a bit of the language. But yeah, you're also somewhat expected to learn the language or get help from, I don't know, other textbooks. They will tell you which ones. If you don't have any clue about the resources, they will tell you which ones to use, right? Yeah, so one thing, for example, in the software engineering, that's one of the fundamentals that I'm teaching. We have used Java combined with AI assistants, so you can use whatever AI assistant you want to help you program, because it's not a programming course, it's a software engineering course, right? So, and then there we've seen maybe one generation of students which didn't use any AI support, and then they visited some of the student projects at the demo of students who used AI support, and they were really surprised about the level of programming that the students are now capable of doing. So all of you should have some basic knowledge of programming, and those who only have basic knowledge, we will try to build that up, and you need to be creative in the resources that you use. You have to check which resources are you allowed to use, right? Not all of them allow you to use any kind of resources, so doing your homeworks only with asking ChatGPT, this might be not allowed, right? So in some courses, they might allow you, but ask before you do it, right? And yeah, don't just upload the whole worksheet to ChatGPT and let it solve it, because that's academic misconduct, and you would get a 0. And then usually if you fail the homeworks many times qualify you for the exam. So if you fail the homeworks, you can't take the exam, which means you have to repeat the course the next year, right? So yeah. Any other questions? Yeah.
What about enlisting and deregistering from exams in each
Yes.
semester?
So if you want to complete a module, usually they are with exams, right? Sometimes you have a project and then an exam on top. So there's an exam registration period. So there'll be an email on the mailing list. This usually opens maybe mid-semester. And then you have time to register for the exams. And you have to actively register for the exam, otherwise you cannot participate in the exam. This exam registration period usually ends I think 2 weeks before the end of teaching, something like that. There'll be a date where you can no longer register for new exams unless you talk to the professors directly that there was, I don't know, some emergency cases and stuff like that. Then they might allow you to still register for the exams, but your basically right to register is then gone. So if there was really something that you were, I don't know, had the flu for 5 weeks or something like that, then they might make an exception. But you should register during these periods, and they'll be announced on the mailing list. You can still deregister from an exam, maybe because you didn't study or your study period didn't work out as planned. You can still deregister from the exam, but that works only, I think, 4 working days before the exam. So you have to deregister 4 working days before the exam, so you can't just decide the night before the exam that you want to deregister, then it's too late. And then this would count as a failed attempt, unless you have medical proof that you couldn't make it to the exam, or that you were unfit to write the exam. But then you really need a certificate signed by a medical practitioner here in Weimar. or well, another German city probably is also accepted. Yes, but they have special forms that they write, like a kind of a sick note that would then still get you out of that exam. But then you're required to provide this sick note. If you still deregister the 4 working days before the exam, then it's fine. Then it's as if you never registered. Any other questions? Yeah?
Related to the exams which you mentioned, if we don't register for an exam this semester, can we take it up in the next semester when they offer the exams?
Okay, so what happens is that usually the courses that you see here, they are offered every year. Some might have another schedule, and then each course might have their own regulations of what allows you to register for an exam. So some say you have to get at least 50% in the homework before you can write the exam. And then they will tell you whether this expires or not. So if it doesn't expire, and then you can still register the next year. If you fail an exam, usually many professorships, they allow you to take it the next semester. So that's like a repeat exam, which is not on the regular schedule, but it's offered maybe for some students. Maybe some only offer oral examinations, or yeah, so you have to check that also with the professorship. But then you can basically take it the next semester as well. And some fundamentals, so for example, in the software engineering, because that's a fundamental and this might stop you from doing your research project. That's why I offer there every semester the exam, even without failing, because yeah, it would be stupid to say you have to fail this exam so that you can do it next semester. But yeah, not every module offers them, only for, so you really have to talk to the people offering the exam. If there are no more questions right now, then there'll be some, I think, coffee at the open area there. So yeah, then welcome everyone. Great that you made it, and hope to see you soon in the lectures. And yeah, see you.
Hast du noch ein paar Minuten?
Ja, ein paar Minuten nicht noch, aber ich krieg Hunger.